Section 6.2 is where you are doing inverses of each other. So your steps to find the inverse, all you have to do is switch the x and y and solve for y. Now they will put it in function notation, which means they're going to have an f of x in there, and that just means we can replace it for a y. So let's take a look. So it asks us to find the inverse of f of x equals 3x plus 2. First step, know that f of x is just y. So put y equals 3x plus 2. Next step, switch the x and the y terms around, or the x and y variables, I should say. Now, just solve for y. So I would minus my 2 to the other side, and then I would come back and I would divide everybody by 3. I would simplify as much as I can. So this would be 1/3 x, negative 2/3, this is just y. I can switch it around if I want the y on the other side. If you want to be fancy, you can rewrite it in inverse form, which means that you're doing a -1 as an exponent. So the inverse of f would be this guy. Pause the video and try the next question. So on the next question, you should have set y equal to negative 2/3 x minus 4. Swap out the x and the y variables, and then start solving. So I would add the 4 over, and I would divide everybody by negative 2/3. So when you divide 1 by negative 2/3, you should have gotten negative 3/2 x. When you divided 4 by negative 2/3, you should have gotten negative 6. So now you can switch it around and put the y on the other side, and you can swap out that y and put the inverse. So the inverse of f would be negative 3/2 x minus 6. Okay, what does it look like when it's not linear? So what would we have to do if we needed to find the inverse x minus 7 quantity squared? Steps are still the same. So I am going to solve. I'm still going to replace them. So I'm going to put y equal to x minus 7 quantity squared. I'm going to swap my x and my y. Now, here's where you want to start solving. Since I'm squaring this whole side, I have to get rid of that squared before I can get inside those parentheses. So that is why I'm doing the square root on this step, so that I get the square root of x, and then the square and the square root will cancel each other out. So that's why I'm left with y minus 7. Now I can add my 7 to the other side. Notice how I wrote it. I did not have this square root sign going all the way across there. So make sure that you only have the square root over the x, because that is the only part we did the square root of. Make sure the plus 7 is not underneath your square root symbol. And then if you want to, you can rewrite it with your inverse function so that you are having the inverse of f. Now, what if I gave you f of x equals x squared minus 7? It's important for you to understand what the proper steps are for solving these. So you still are going to put y equals. You're still going to swap these out. But consider what your next step would be to solve for y. This is different than this only because I'm squaring that whole expression. On this one, I am only squaring the y. So my first step over here is going to be adding that 7 first. And then I'm going to come back and do my square root of that other side. Okay? So be careful when you are writing those because of that fact. All right, so that takes care of part 1. Looking at part 2, we are still looking at finding the inverse, but now we're going to also describe what the meaning is in a word problem. So a formula for converting temperature in degrees Fahrenheit to degrees Celsius is this function here. We have to find the inverse of that function and describe its meaning. Steps have not changed. Still set it equal to y. Swap the x and the y around, and then start solving. So what I would do is I would divide by 5/9 over here just to get rid of that fraction. And that's how I got 9/5 x, because I did 1 divided by 5/9. And then I added that 32 to the other side. That's how I would do it. You do not have to do that way. You can distribute that 5/9 and go that route as well. But that's how I decided to make it look a little bit cleaner. Okay. So then the second step is it's asking you to describe that meaning. So this formula went from Fahrenheit to Celsius. So my inverse has to go the other direction. That's what an inverse does. It takes you back to where you were. So that means I'm going to be converting Celsius degrees to Fahrenheit degrees. That's what this inverse function will find. So the inverse always swaps it out and makes it the opposite direction. So if I was going towards the gas station, the inverse of that is I went from the gas station back home. Okay. Then the next part is, how can I verify if I have inverse functions? Now, I'm going to be honest, I don't teach it the way the book is. The book wants you to use composition, which I think is a little silly because I think you can figure out if they're inverses just by finding the inverse. So I take that first one and I find the inverse. So the same steps we've already done. So y equals, swap the x and the y, and then solve. So I minused my 4 over and I divided by 7. Are these the same? Yes, so those would be inverses. So I choose to just solve this for the inverse, and then you can determine if they're inverses or not. Pause the video and try this next question. So I took my first one, I set y equals, then I had to I had to switch the x and the y, and then I had to square that other side in order for me to get rid of that square root. So that is what I did on this step right here. And then I had to minus that 13 to the other side. This is not the same as this guy here. So no, they are not inverses. So not too bad. Finding inverses, just swap the x and y's and then solve for y. That's really all you're doing. And then thinking about it logically, inverse takes you the other direction. So if I'm at home, I go to the gas station. The inverse would be from the gas station back home. That concludes section 6.2.